Okay, so our next problem we're going to be working on is number 4. It's a hard one. Woohoo! So I'm excited to do our first hard problem. I think hard problems are probably going to be more interesting. That's the only reason. So actually, I don't think this problem is too hard though, but we'll see. I think they're being a bit generous with their hard there. But okay, so we're gonna do this. So what they do is they give us two arrays, and actually it's a vector. Rest, a vector is different from an array, but obviously they named this before they created a Rust problem. So in other languages, it's probably an array. In Rust, it's a vector. So it passes us two vectors called nums1 and nums2, and they both very appropriately contain a list of numbers. So nums1 contains 1, 3, and nums2 contains 2. And so we have to essentially combine these two numbers and get the median of them combined. Sorted though. So they're already sorted. So we have to get the median of, if they were both combined into an array, get the median of that was. And so if there's, so for this one, there's three numbers, 1, 2, 3. If these were both combined into a sorted array, it'd be 1, 2, 3, an array of 1, 2, 3, and 2 would be the middle, which is the median. We could do, for this one, since it's an even number, there's going to be two middle ones, 2 and 3. So we will just add 2 plus 3 divided by 2, 2.5. Simple enough? Okay. So I've already pre-baked in the starting code here. And so let's get to work. Let's just go ahead and return 0.0 just to get that red squiggly away. Go away, Mr. Red Squiggly. And we need to, so first thing we can do is something probably a little inefficient. We can just combine both vectors into a single vector, a single sorted vector, and then we'll just find the median of that, because that's like the simplest approach, and then we'll do the efficient approach. Okay, so let's just create a result vector, which will be just an empty vector at first, and then we'll just push each number onto this vector. So we'll just cycle through both of these. So we'll just say for I in 0 till the total of nums1, the total number of items in nums1 plus the total number of items in nums2. Hard to type while you're doing that. And so this will give us, this will let us cycle through. We don't actually need the index. This is just so we can loop through every single item in both of these. And so we'll get the first number will be nums1. So we'll need to keep track of two indices. We'll need to keep track of the index we're on for the first one. So we'll start out at 0 here, start out at 2 here, and then for this one we'd increase to the next one, which would be 3, and then we compare 2 and 3. 2 is larger, so we'll go to the next one and 2, although there's not one. So the next one would be 3. So essentially we'll need to keep an index for both of these vectors. So let mut I equals 0 and j will also equal 0. We could make this a little neater. We could put this on one line. I don't know, I think I might start doing this. I kind of like this style a bit. Looks like a guy. Oh wait, never mind. Don't want to say what that looks like. Anyway, sorry. So we will get the first number will just be the index I of num1. So we'll let num1 equal nums1 index I. And then we will say let num2 equal nums2 of index j. So j is keeping track of what number we're on, the index number we're on in num2, and I is doing it for num1, nums1 array. Okay, so now we've got both of these, so we need to see which one is larger. We need to see which is the smaller one, and then add that one to the result array. And so we'll go through each smaller one, and so it'll be in ascending order of arrays. And what we could do is, I suppose, just concatenate the two arrays, then sort them, then find the median. That'd probably be even easier. But let's just go ahead and do this because we're gonna need to do this anyway. For whenever we do the efficient solution. So this is a bit more explicit. So let's say if num1, I just thought of that while I was doing, is less than num2, then we'll increment the I index, and we will push the num1 onto the results array. Oops, push. Okay, hard to type and think at the same time. Otherwise, we will increment j and push j on, and push the second number onto result. Okay, so the smaller number is getting pushed to the result, so that gives us an ascending ordered array of the combined two vectors. Okay, and so then we need to find the median. So this will give us, that should give us the result. So let's just print this out to the console just as a sanity check. We'll have to use the debug trait there if I can type it. I'm struggling. Okay, so, and we'll print out the result. Obviously the test is gonna fail, but, so what happens here now is we're accessing a number that doesn't exist. So whenever we get to 2, for j, so j will be 0, then we add it to 1. And then the next time we get the j index of num2, and that doesn't exist, so it's panicking, and we're not even able to print our result. Okay, so good thing we did that. So let's go ahead, and instead of just accessing the array directly, let's use a get. And so what this will do is return an option, and it will return none if there is no number at that index, and it will return the number if there is, wrapped in an option. But unfortunately we can't compare num1 to 0, and since we're getting the smaller number, we'll just take this one out of the equation and make it the max number possible. So we'll say or sum, and then we'll just get the standard I32 max. And so that will get the maximum number, so it will always be the second one, the other one, if this one doesn't even exist. And we can do the same thing for num2. So we'll just replace that with 2, replace that with 2, replace this with j. And so that should work. What's wrong with this? We're getting a little error there, but we'll see what that is, what that error is. Expected ampersand. So it's expecting a reference. That's good. Okay, it's a good thing it said that. So now we're getting 0, but it's printing out the correct array now. So we know that we're getting a sorted combined array by doing this. Okay, so next thing we need to do is find the median. So the median is just going to be the total length divided by 2. And then that will give us, so if there's 4 items, so 4 divided by 2 will give us 2. So 0, 1, 2. And that would be the third item. But we need to get the combined, since it's even, we need to get the combined of both. So we would go back 1 and then add those 2 together and divide by 2. And if it's an odd number, then we would take, say, 3. So it'd be 3 divided by 2 equals 1.5. And we're going to cast that to an integer. So that 0.5 value will just be truncated, and that would be 1. So that would actually give us the median for 3 just by dividing by 2. Again, so for an even number, we need the total divided by 2, and then also the element before that element, combine those together and divide by 2. And then, sorry, this is a little complicated, and for 3, just divide by 2, and that's going to give us the number because it's going to round down. Okay, so we can say the total median is Well, let's get the total length. Just so we're going to be writing this in multiple places, so we don't want to repeat ourselves. Stay dry, DRY, don't repeat yourself. So we'll go from 0 to the total length. Oops. Total length. And then we can get the median. And that will just be total length divided by 2. And since these are both integers, that will actually, that's a usize. But since we divide, that will round down. So it will truncate the decimal point. Okay, so, and then we'll just iterate up to, well, we don't need the median. You should always have your variables as close as possible to where you're using them, so we can bring the median down here because we're not using median up there, and it's closer to the logic of where it is used. Okay, so for the median, so we will get, so if total length is even, so if total length mod 2 is equal to 0, that would mean that the total length is even. We would return the result I of the median minus 1. So remember, we're getting the one, if there's 4, we're getting the one previous to the median, which would be this one right here, which would be index 2. 4 divided by 2 is 2. So this would be 1 and 2. And then we need the 2 plus result median. So this would be 1, 2 if the length was 4. And then we will divide, and we need to cast this to an F64 and divide it by 2.0. And that will do it for this block. Let's see what's wrong here. So this returns a pointer, so we actually have to dereference that. And also we need to go ahead and unwrap this because this is going to return an option, but we don't need to plan for having none. So this will panic if this returns none, but since we give it a default value, we don't have to worry about that panicking. Okay, and so we can go ahead and run this, and obviously it's still 0. So that should give us the right answer for an even, but we also need to plan if it is odd. So otherwise we'll just return result median, because remember the median returns the correct number as F64. And then so, oops. Actually, we don't even need that else because we have a return statement in the if statement, and we're just returning this. So this should give us the right answer. Okay, so our tests are passing now. So let's go ahead and paste that into our Leetcode and see what they think about it. See how well we do. Alright, so we'll submit that. And this is the less efficient solution that we're going to be doing. So it's 8 milliseconds and 2 megabytes. So that's actually, the memory usage is fairly good. But the 8 milliseconds is pretty slow, I mean, compared to other REST solutions. So that's actually pretty fast though. So what we need to do now is we only need to go up to this median, because the maximum one we're actually going to need is the median. See, we get the median minus 1 or the median. So we can just get rid of this vector anyway, the result vector, and we can just keep track of the current one and the last one, because we will also need the last one for this one. So if we're iterating through the array and there's 4, we need to be able to get that last value plus this current median. So we just iterate up to the median plus 1, because 0 indexed. And this is up to, or we could do, instead of this, we could do up to or equal median. And that is the same thing. And now that we're using the median up there, we need to move it up there, up here. And we might not even need that total length. I'm just going to leave it there for now. So instead of pushing the result, we're going to have two variables. We're going to keep track of the current one, and we'll just set that to 0. So if there is nothing returned by the array, essentially we'll just return 0 if it's two empty vectors they give us. And we'll keep track of the last one as well. And so we'll set, so if num1 is less, then we'll set cur equals to num1. And if num2 is less, we'll set cur equals to num2. But we also need to first assign last equal to whatever the current one was, and we'll do the same thing down here. And then instead of getting this result, let's see what's wrong here. We actually need to make this dereference that. Okay, so that should be good. And now instead of getting from the array, we'll just return the last and the cur. And here we'll just return the current one if it's even. Okay, so hopefully that was pretty easy to understand for you. So I'm just going to take all this code. Oops. I deleted all my work. I didn't even push it. Okay, I don't know if I'd copy that. I'm still kind of getting used to VS Code and using Vim in it. So let's paste that. So this should give us 0 now. So it's 4 milliseconds. And so this just gave us 100%. So 0 milliseconds and 2.1 megabytes. I didn't really change anything other than just putting this variable into just importing it and using the same variable. So that seems to have speeded it up a bit. Okay, so let's look at other people's solutions. So these people are shooting for 12.7 megabytes, and that's better than the rest of the solutions for Python. Man, glad we're coding in Rust, huh? And 92 milliseconds. We just got 0 milliseconds. That's faster than 90. So that's pretty amazing. It's funny to watch people who have way slower programs. 100 milliseconds, so that's JavaScript, obviously. That's going to be slower. Let's see. 92 milliseconds. Golang, they don't say. Here, it's C++, binary search faster than 98%. Wow, so yeah, Rust is, in conclusion, Rust is really fast. So let's look for the Rust solutions, and we'll compare ours. So here's one, 0 milliseconds. And so this guy, it looks like he's actually creating a temporary vector, and he's pushing every single number to that. So this was our inefficient solution that we essentially did. And then he's using his find middle, and then he has this, if nums1 is empty, find the middle. So if there is no, so this, we didn't have to add this because we account for that in our while loop. So I'm gonna say ours is better than that one. Okay, we could change this into a while loop. That might be a little neater. So while I plus j is less than or equal to median. We don't need these parentheses though, because of the order of execution. So that should still work. Okay, so that works too. That's a little neater than the other one. So let's see how fast this is. I'm just wondering if going through that iterative loop is going to be slower than adding the two numbers together every time. I think this might be slower. I honestly don't know. Let's see. We had 0 milliseconds before. We'll see what this is. So this is 0 milliseconds too. Okay, so I mean, I think that's slightly neater, so I'll just keep it like that. Okay, so we're using a while loop instead. So even though our solution is pretty much better than this one, we can still learn from it. We can still take pieces of what he did. Okay, if we really wanted to be lazy, what we could do is just combine these two vectors and then sort them and then find the median of that. So we could basically go back to our old code. So we'll keep that length, and we'll just say let combined, or let mute combined equals nums1, and then we'll just extend that combined to include nums2. And so now that will give us the combined, and then we will sort the combined numbers. And so then we have a combined sorted list. And so we can delete all this code. All we need now is to return the result. So we'll say combined median -1 plus combined median. And we'll need to wrap that in parentheses. And then we will return the combined median if it's an odd number. If it has an odd number of elements. Okay, so let's see if that works. Alright, so that works. Except we don't need this anymore. So we'll see how efficient this is. So this is lazy. The extension is lazy, so it retrieves each element in the array lazily, but since it's sorted, I don't think we'll get that lazily lazily consumed elements of the arrays, because it has to know every single element in order to sort it. But I think it'll still be an O log n problem, but it's just we do a little more work. Our other solution is faster, but we can try this. And it'll probably say 0 seconds, I'm guessing. So at 4 seconds, we could try it again, probably and get 0 seconds. But this is theoretically slower. So yeah, we got 0 seconds, so it's probably about the same time for what they're using for. They really need to start measuring it in nanoseconds for Rust and have this be more accurate, because Rust is so fast. They're probably not used to that. But okay, so the next video we'll be looking at the longest palindromic string. So yeah, join me in the next video, why don't you?